This video aims to provide a quick explanation of my patch, which generates melodies in a partially random manner while respecting the rules of musical harmony. I invite you to test it by downloading it from the link provided in the description. Let's now listen to an example of a melody created using the patch. The patch is primarily built around the Basically module from Stochastic Telegraph. To allow you to customize the program entered in Basically, some information about its structure is provided at the end of the video. However, this is a section that doesn't need to be inspected and understood to use the patch. Around it are several other modules dedicated to entering user-selected parameters. This parameter defines, among other things, the key and mode of the scale used, as well as the tempo to be applied to the melody to be generated. The patch also includes a module offering 4 outputs to which the users can patch their favorite synth voices. This is a volt per octave output delivering the pitch of each note in the melody. A second polyphonic volt per octave output delivers the chord notes. Finally, 2 other outputs deliver gate signals for the notes and chords. To use the patch, the very first step is to choose the scale in which you want to create the melody. To do this, select the tonic of the chosen scale and its octave using the 2 dedicated buttons. Similarly, you then choose the scale mode, which can be either major or natural minor. Based on these choices, Basically will harmonize the chosen scale. To simplify matters, it will determine which 7 possible chords, major or minor, can accompany our melody in the chosen scale. The second step now consists of choosing, from these 7 chords determined by Basically and using the dedicated fader, which 4 chords will actually be composed around our melody. For each chosen mode, the patch offers 10 possible series comprising 4 chords. Each series is designated by the degrees of its 4 chords. For example, the number 1 series of 4 chords corresponds to degrees 1, 5, 6, and 4 of the scale. If we decided to create the melody in the C major scale, Basically deduces that the future melody must be created around the 4 chords C major, G major, A minor, and F major. These 4 chords correspond to the harmonization of the 1st, 5th, 6th, and 4th degrees of the C major scale. Let's now look at the process used by Basically to generate the notes composing the melody associated with each chord. For each of the 4 selected chords, the program creates a succession of 8 notes, respecting 2 constraints. First, for each chord, 5 notes will be randomly chosen from among the triads composing the chords. Next, to obtain our total of 8 notes per chord, Basically must add 3 so-called passing tones. To simplify, a passing tone is a note that does not belong to the chord in question but is there solely to ensure the transition between 2 notes taken from the chord. Note that passing tones can sometimes create a slight dissonance. In the end, we have an 8-note melody for each of the 4 chords in our scale. To play the melody, however, it will be possible to use fewer than 8 notes, as we will see later. The next step is to specify the order in which we want the melodies for each chord to be played. To define this order, we apply the convention of numbering the chords from 1 to 4, based on the initial choice made from the 10 available sets. In the example seen previously, this amounts to assigning the number 1 to the C major chord. The G major chord is number 2, A minor is number 3, and F major is number 4. It is based on this numbering that we then memorize the order in which the melodies are played. This is done by entering, in the slots of the dedicated 8-face module, the numbers of the different chords that will be played successively. When defining this execution sequence, it is possible to repeat or omit one or more chords. It is also possible, for any chord, to reverse the order in which the notes of the associated melody are played. To do this, simply assign a negative value to the chord number. The length of the sequence is limited only by the number of slots available in 8-face. If necessary, other +8 expansion modules can be added. If you want to retrieve the sequencing order you've defined later, simply save it in the dedicated 8-face module. Furthermore, the melody can be repeated in loops during playback. The desired number of repetitions is indicated to basically using the dedicated fader. The next step is to define the duration of each of the 8 notes in the melodies. These durations, which will be identical for all chords, are entered using the values assigned to the 8 buttons of the models module. A value of 2 corresponds to the duration of a half note. A value of 1 corresponds to the duration of a quarter note, and a value of 0.5 corresponds to the duration of an eighth note. 2 important notes. Choosing a negative value tells basically that the corresponding note should be replaced by a rest of the same duration upon execution. Choosing a 0 value tells basically not to play the corresponding note. To be able to be retrieved later, each series of 8 duration values can be stored in a slot of the 8-face module dedicated to this task. Note that while a piece is playing, you can recall a series of previously stored duration values by selecting the relevant slot. This allows you to modify, in a running instance, not only the durations of each note in a chord, but also the number of notes to be played in the chords. For this purpose, a double 3 Malawian kwacha's trigger generator allows the slots of the 2 8-face modules responsible for memorizing length patterns and memorizing sequences to be advanced during execution. The very last step is to choose the tempo at which the melodies will be played. This is done using the dedicated fader. All settings are displayed, either during input or during performance, by the control panel. Let's now take a closer look at some of the patch's features. Each 8-face module is associated with one or more other modules in the patch. Using the Bound Modules option in its context menu, you can display the modules associated with it. If you reset the 8-face module, you'll need to make sure to re-establish these associations. V. Let's now see how basically handles the various notes of musical scales. During the program's initialization phase, 28 notes are assigned to a first table called interv depending on the major or minor mode chosen. Each value represents the note of the successive chords harmonizing the C scale. Thus, for the major mode, these are the chords C major, D minor, minor, F major, G major, A minor, and B diminished. For the minor mode, these are the chords C minor, D diminished, E flat, F minor, G minor, A flat, and B flat. These notes follow in sets of 4, each set corresponding to a distinct chord. The first 3 notes in the set represent the triad in question, and the 4th note represents the octave of the chord's root. Since these notes are based on octave number 1, basically we'll then apply the necessary offset to them so that they correspond to the tonic and octave chosen for the melody to be generated. A second array, called prog, consists of 10 sets of 4 values corresponding to the chord patterns. Each set represents, in the selected scale, the 4 degrees of the chords of the pattern chosen to generate the melody. Basically we'll generate the 4 chords around which the melody will be built. Finally, the values of the individual note durations entered by the user are stored in an array called rhythm. The rest of the basically program, which manages the actual creation of the melody, is documented at each step. This concludes this presentation of the patch, which I hope may be useful to you. Enjoy it.